Hi, everyone. Here we're going to be talking about now unsupervised learning, and we're going to be talking about topic modeling as a kind of unsupervised learning. So let's recognize that when we have a document, such as a scientific article as shown over here, this document may have multiple topics. So one single document, for example, may be about genetics, it may be about computation, and it may be about life sciences. Now, how do we identify these topics from an article or a set of articles? Well, this is where topic modeling comes in, and the approaches to topic modeling, such as latent Dirichlet allocation, which is one of the state-of-the-art top ways to do topic modeling. But notice that what we can do too, as this diagram suggests, is that we can identify topics by extracting certain words of the text, the documents we're looking at, and putting them together. So the words gene and genome and gene sequencing go together, and they kind of all aggregate or cluster in this genetics kind of topic, or which you just called by maybe the first word, gene topic. Another set of words, such as numbers and computer and predictions and computer analysis and computation, all aggregate or cluster in another set of topics. They all seem to be related to, well, computation. And then other terms such as survive, organism, life, organism may all cluster as another set of topics. And this identification of these keywords from a set of text into clusters of similar meaning words is called topic modeling. So the intuition for this kind of analysis is that documents are a mixture of topics. So one single document may be about genetics, and certain terms may have different kind of probability or weight to be related to this topic of genetics. Other numbers will be, other words will be related to maybe something more related to computation, another by life sciences, or maybe another set of terms are going to be related to something we can call anatomy. And each of these may be distributed differently in a particular document. So the document we just saw is mostly about genetics, computation, life sciences, but very little about anatomy, not that much, and so on. So topic modeling is an unsupervised approach to text classification, where a set of topical keywords are extracted from a set of documents. So in a simple way, we can think of topic modeling as this. Topic modeling generally works by identifying frequency and co-occurrence of words across a set of documents. So it's usually not just a single document, it's applied across a set of documents, and that's how it is able to actually cluster the words that are similar. Note that this assumes a clean data set and sort of pre-processed data set, which we talk about. So things like stop words or words that have less meaning for topics, such as articles or conjunctions and other parts of text are removed. Words are maybe all the words are lowercase, so we can match, topic modeling capitalized with topic modeling lowercase and so on. Words are stemmed to their root. So things like, well, plurals are eliminated, right? So if you have the word house and we have the word houses, we want to get rid of that S so the computer can match house with house. And because if you try to have the computers match house with houses, you may say, wait, that's not the same word. One has a different letter. And in this example, it's easier because house is within houses, but houses is not within house. And also there are other kinds of plurals too, right? So, well, child and children, kind of the same, but, ran and run. Ran and run, similar root to run, but they are not the same. The computer is not going to be able to recognize this is the same word. Generally, the number of topics needs to be determined a priori as well. So that's kind of makes things complicated. You don't really just put in a set of documents and then it tells you how many topics there are. You have to know how many topics there are first, which makes it topic modeling a very difficult and sort of necessarily iterative kind of task. You will maybe try to model with 10 topics, see how it comes out, see if the topic lists make sense. If it doesn't make sense, then maybe you will increase or decrease the number of topics. So this is part of the parameter manipulation. Also, each document should be relatively long. So if you just have a document with like 5 words or something like that, your topic modeling is not going to work well because it really does need to find this frequency and co-occurrence of words across multiple documents. And the model, that is the topic modeling model, needs to be applied to several documents, what we call a corpus. A corpus is a set of documents. So each document should be relatively long. So it works best with like a scientific article, a news article, and works less well with like a tweet, although those social media posts can work as well. And you have to have several documents. You have to have a corpus of documents to apply topic modeling. I'm not sure if this can be a little bit confusing, but just to provide another way to visualize what's going on here in topic modeling is there is an estimation phrase that needs to happen when the model process, and these are also called generative models, which is kind of another word for unsupervised or models or kind of clustering models that just learn from the data itself. And there is first and kind of inference or estimation in topic modeling of how each words are distributed across the documents. So we can think of these as kind of a bunch of documents. And once the model learns how a particular set of text or particular words are distributed across documents, it gives them certain values and then generates a result of these kinds of lists of words that may indicate topics of a set of documents. Okay, so there's this inference estimation first that the model itself does, and then there's the generation of a list of topics. There are different models for topic modeling. You can sometimes theoretically use what is called TF-IDF, which is calculating the term frequency. So for each term in a set of documents, the word gene, let's say, is one term in a document, calculating for each of the words in the document, for each of the terms, calculating their frequency, and then divided by the inverse document frequency. That is how rare or not each term is across multiple documents. And that is because if a document has, for example, a lot of the word gene in one document, but it's not frequent in other documents, then this document is about gene, and then the other document is about, maybe Harry Potter. So this TF-IDF measure, which is very common in text analysis, can be used for topic modeling, but it usually will require some other kind of clustering approaches afterwards to actually be implemented. So often the models for topic modeling are latent semantic analysis and latent dirichlet allocation. And these are fairly complex models, but they often are relatively straightforward to implement at first. So they're kind of difficult to understand. They're complex, but because they're already integrated into Python libraries and tools, they are easy to implement. And maybe we can do an exercise with it in this class. But these are some of the ways that topic modeling are actually analyzed. To have an understanding of the process in more detail, here's an example of a pipeline. So for example, if you're looking into Twitter data, first you need to scrape Twitter, you got the Twitter data. You want to load into Python, you might load into a structure like pandas as we have used. Then we need to clean the data, so remove things like emails and URLs and emojis. Now this could be useful for topic modeling, but often they just complicate the analysis, so we want to remove all that. And then we also need to do another pre-processing as we talked about. So things like lemmatized is similar to stemming. So going to the root of the word. We need to tokenize, so turn the text into the specific words that we want to have. So things like bigrams or trigrams or unigrams, as we mentioned. We want to remove the stop words. So remove things like adjectives, a, the, conjunctions, but, my, theirs, pronouns, maybe theirs, his, and so on. So there's a lot of cleaning, a lot of pre-processing. It's not just a fully automated process. Then there's this part here, you convert text into ID word dictionary. So this is the part of the identifying the term frequency. So how much each term appears in each document. And then you convert text into a token ID, token count. This is kind of like all related of calculating how the frequency of the terms in each document. And then we actually apply the LDA model itself to this numeric conversion of the data to develop the list of topics, which can be things like a word cloud. When you see the word clouds, this is a kind of topic modeling. This is a kind of topic modeling approach. And often it is just kind of one word cloud you will see, but topic modeling will result in a list of lists of sets of words, as we saw over here in the topic one is a list of words, right? Multiple lists. The topic modeling results in multiple lists of words, and that's the general result of topic modeling. So topic modeling is a type of clustering approach that identifies lists of words from a set of documents that can reveal what we can think of as topics. Topic modeling requires a substantial amount of pre-processing and knowledge of a number of topics to select. Generally, this is an exploratory approach for text analysis. And next time, we will have some more practical applications of all this information. And until then, see you next time.